Hi students, good morning to everyone. The topic that will be discussed today, cohesion. Cohesion and cohesive modules it perform a single task. In the previous sessions we clearly discussed about what is module. A module is a smallest unit of the software. A software is divided into numbers of pieces. Among one piece is called a module. Combining all modules can make a software. A cohesion it performs a single task, and it describes how an internal elements of an module is binded tightly each others. A cohesion is a measure of the degree to which the element of the modules are functionally related. In a module, the statements is to be related each other. It is the degree to which the elements are directly towards performing a single task, and combining all the statements say it perform a single task in the component. Basically, cohesion is an internal glue, internal binding that keeps the module together. A software design will have high cohesions. However, statements are related to each other in a module is known as an cohesion. A cohesion can perform a single task. There are the numbers of the cohesive modules are to be discussed here. Functional cohesions, sequential cohesions, communicational cohesions, procedural cohesions, and temporal cohesions, logical cohesions, and last one is a coincidental cohesions. We will be discussing in these sessions one by one. Functional cohesions, the functional cohesions which perform a single task. See the definitions. Every essential elements for a single computations is contained in the components. A functional cohesions perform the task and functions. It is an ideal situation. It is clear that the functional cohesions which perform a single task. Next we go to the sequential cohesions. Sequential cohesions input of the other element, the flow between the among the modules. However, it is say an elements of the output some data that becomes the input for the elements. The data flow between the parts. It occurs naturally in functional programming language. Earlier I said that a cohesion it perform a single task, but here is the process of the input of the next process. One process is completed, the output of the process completed process is the next put of it is the input of the new process. So finally it perform a single task. So an elements of the output some data becomes the input of the other elements. So when a task is completed, okay, a process is completed, the process output, the process A output is the input of the process B. Finally it completed all the process sequentially. Okay, one by one the process are completed, and finally it provide the output is known as an sequential cohesions. Anyway, it gives a single output. However, it performs the single task. It is known as sequential cohesions. Communicational cohesions. Two elements operate on the same input data, contribute towards the same output data. Example, update records in the database and send it to the printers. Here, two cohesions and two elements are to be perform the same task, but they are to be different. It is logically same, but it is physically different, and they are to be contribute the same data that are to the same parameters that given by the user. For example, updating the record and simultaneously the data is sent to the printers. So simultaneously two tasks are be performed is known as an communicational cohesions. Now we come to the procedural cohesions. Elements of the procedural cohesions ensure the order of the executions. Actions are still weakly connected and unlikely to be reusable. Example of calculator the student's GPA and print the student's record. Calculate the cumulative GPA, print the cumulative record. So here the data is to be, the elements is to be processed procedurally. And it not accept the poor structure. It is clearly said elements of the procedural cohesions ensure the order of executions one by one. It must be used the procedures. So order-wise the elements is to be executed in the order-wise. And it not be actions are still weakly connected and unlikely to be reusable. So it not be support to the poor structures. Example, calculate the student GPA and print the student's record, right? So it is a, when we are calculating the student's GPA, we have to be take the print of student's GPA. Suppose if we are calculating, if we are doing one task, okay, when we are taking as an some other task, so we are performing, we want to be performing some other task, so it not be permit. However, we are copying a file and we want to be share a file at the simultaneously, so it is a non procedure, so it perform the task all are to be in procedure, okay, in linear order, right? The second examples are given. Calculate the cumulative GPA, print the cumulative GPA, then it will be accepted because of we are performing the task is and calculating the GPA and we are wants to be take a print of a GPA, so it is in procedure, okay. One task is completed and the same task is to be processed in the memory, right? One task is the both are to be same task are to be processed in the memory, that are to be permitted in the procedural cohesion, right? And it is in linear orders of executions of the element or process. The next one is in temporal cohesions. It is the concurrent executions of all tasks is known as a temporal cohesion. See the definitions. The elements are related by their timing involved. Your modules are connected with the temporal cohesions. All the tasks must be executed in the same time, which means concurrent executions of all tasks. This cohesions contains the code of initializations. All the parts of the system. Lots of different activities occur all at in it time. So simultaneously numbers of the task is performed. However, concurrent executions of all tasks, the technique is used in the temporal cohesions. Logical cohesions. The elements are logically related, not functionally. For example, a component's read input from tape, disk and a network. All the code for these functions is the same component. Operations are related, but the functions are significantly different. In the logical cohesions, elements are logically related but functionally different. However, the code is to be read simultaneously same in the tape, disk and in the network, but it is logically the code is related, the task is related, but functionally the task is different. It is in performing the task is different. We are reading the code, the same code from the tape. The task, the functionally the task is different. From the disk, the task is different. From the network, the task is different. But the logically they are all be the same task. Right. The next one, coincidental cohesions, which means same code recognized for some other modules. However, see the definition. the elements are not be related, unrelated. The elements have no conceptual relationship other than the locations in the source code. It is accidental and the worst from the cohesions. The print next line and example as an print a next line and reverse the characters of the string in a single component means same code recognized to the other modules. Right? For example, we are taking a we wants to be share a file and we wants to be take a copy of this file. Right? So that ought to be not permitted in this confidential cohesions. However, if you are reading a data in order wise and printing a data in descending order wise. So in ascending order wise we are reading a data and descending order wise we are taking a print. So such types of the cohesions is known as confidential cohesions is not permitted in this way. Such are to be unpermitted. So it is clear the cohesions it perform a single task and it describe that how the internal elements of a modules are binded tightly each other, and it can be classified into 7 different categories. And first one is functional cohesions which perform a single task, sequential cohesions which perform the operations for a single task. So the elements is to be or the process is to be the numbers of the process is to be completed, right? For example, say the process are 3 process are there A, B, C. So A process is completed and the output of this A process is sent to the B process, and B process is completed, the output of the B process is sent to the C process, and finally the C process is completed. So these are all be combined into a single task. The sequential cohesions which perform the sequential process and a single output. Communicational cohesions, 2 elements may be operate. 2 elements are to be share the same data. For example, updating a record and taking a print. So these are these 2 processes are to be share the same data. And procedural cohesions, it accept in the linear order of executions. It is not be permit as a non-linear order of executions. So if we are taking a print and if we are for examples if we are share the same copy and if you want to be copy the same file, so that ought to be permitted. Suppose if we are to be share the same file and copy some other file, it not be permitted in this procedural cohesions. Temporal cohesions, which means concurrent executions of the same task, when the numbers of the outputs may be get, however the numbers of the tasks are executed, therefore we may be get numbers of the output at the same time. So that activities that difficult process is performed by this temporal cohesions. Logical cohesions, so some of the process are logically related but physically it is unrelated. For example, if you are reading a text from the tape and if you are reading a text from the disk, if we are reading a text from the network are to be logically same but physically the tasks are to be different. That ought to be supported by the logical cohesions. Coincidental cohesions, which means same code recognized to other module, there is no relationship. For examples, we are copying the file and sharing the file. So the same code is recognized to the other modules. For example, if we are taking a print in the reverse order and we are reading a file in order, so that ought to be unsupported in this coincidental cohesions. With this topic, I would like to be conclude this session. We will be meet in the next class. Thank you very much.